This conference will now be recorded.
All right, so let's begin. Good afternoon again, ladies and gentlemen. I'm going to be doing, even though I said a little bit earlier on, I won't cram too much in, but what I want to do today is finish up arrays. So we're looking at dynamic arrays today. And we are also going to start and complete inheritance. Okay. Now, just let us refresh a little bit. What's an array? Somebody tell me, what is an array? Go ahead, unmute your microphone and tell me.
It's a storage space, miss.
It's a what?
Storage space, miss.
A storage space? What's
Yes,
so
miss.
special about it?
Because you put the amount of variables it can hold, miss.
It's only stores variables of the same data type.
That's right. Okay, so both of you combined did the same thing. Now, last week, what we looked at were one-dimensional static arrays, meaning that you would have created or declared an array of a fixed size. And, well, once you have declared your array, that's it. Now, let me open up a blank page. All right, so when you do that, what happens is that you create a file, a storage space. You reserve a storage space in memory that looks like this, and it has allocated spaces. Now, if this one is X, the indices would start at 0, and it would go all the way up to 6. So that means the size of X, when you're declaring it, what would the declaration look like? If it is holding floating point numbers.
So float X.
Float
Instead of 7.
X.
Square bracket.
Float X what?
Square bracket.
Square bracket.
7.
7.
Within the bracket.
And you could leave it like that. You could leave it like that, or you could say where's my eraser? Where's my eraser? Or you could say float X 7 equal equals 0. What's the difference between the first and the second? What's the difference between the first declaration and the second declaration?
The first one would be empty and the second one would have
what?
First one, random values are stored in the slot, the variable X. And then for the second one, is that 0 in the bracket? I think 0 is stored in the slots.
All right. So with the second one, you end up with 0 filling the array. All right, and you prefer to. And that is because you're cleaning out the array. And that's wonderful. Now, the issue, ladies and gentlemen, I can read your chat. Okay. The issue with the static arrays, as we have them here, is that one, we have, well, let me just move this and let me just go to what the issues are. Oops. That's what happens when you change. All right, let me start over. Okay. Let's start over. And that's X, and it's all filled with 0. Okay. And that would be 0, 1, 2, 3, 4, 5, 6. All right. Now, there are a number of issues with this. Whenever you do this declaration, either of them, when you're declaring your array X, what will happen is that on declaration, what the computer is supposed to do is to reserve 7 spaces that can hold floating point numbers. Now, each float uses up how many bytes of memory? How many bytes of memory does each float use?
Is it 2?
No, not 2. It's 4. I think somebody said 4 bytes. All right. So how many bytes would either of these use? How many bytes of memory would X use or require?
It's 28.
28.
28 bytes. Now that's a small amount of bytes. So that's not a problem. But what if you have a very large array of floats? Say you have an array of 500,000 variables, yeah? 500,000 elements, and each of them is a double. 500,000 times 8 is how much? Come on.
4 million.
4 million.
Okay, 4 million bytes. And 4 million bytes is the same thing as what? 4 kilo or 4 megabytes?
4
megabytes. All right. Now imagine that you have a program with a number of these arrays. And you're running this program. What will happen is that your RAM will slowly or will over time become filled up because you have declared all of these storage spaces here in your array. Now, the problem with that, if your RAM gets filled up, what will happen is that your program will start to slow down and slow down and slow down until it stops, because the program just has no more space to declare any other variables, and therefore it cannot run. So in using static arrays as we have here, we have to be careful that we don't fill up the RAM. All right. I have had this case occur in an assignment I gave my students some years ago, in that how they had declared their arrays. It caused a problem when I was running their programs, the assignments that they submitted to me. It really couldn't run. I had to reduce my I had to reduce the amount of times the operations were allowed to happen in order to get their programs to run. And that can be difficult. And as I say, it can hurt your programs. All right. So how do we get around that? Because as I said, this is what it looks like. All of the elements in the RAM have to be beside each other, meaning that when the array is being declared, there must be 28 bytes for X, this X here. There must be 28 bytes that are available beside each other in order for X to be declared. All right. Most times that is too small for that to even make a difference. However, we know that this doesn't always happen. I don't know how many of you have gone through the utilities in your computer and you're able to see how fragmented the storage space is being used. You know, you have one program running here, another program running there, and you have little bits of or a few bytes here and there between programs, yeah, or between data in the RAM. And what can happen, or what should happen, is that those available spaces should be beside each other in order to let programs run. And you have to go through a process called cleanup or optimization in order to shift some programs so that it frees up storage space, or it makes all the available storage space beside each other. And that will allow other programs to run. Now, what do I mean by that? Say if I have some, this is my storage space on my computer. If it is that I have some space available, say I have an array here, and I have this as X, and I have 0, 0, 0, 0, 0. That's what, 5, 6, 7. This is X, yeah? And then I have, nothing can go here because nothing can hold right here. So I have Y coming here, which is 53, 6, 9, 25, 1. And all of this is Y, yeah? And then I have Z over here, which is 2.5, 0, 0, 0, 0. Yeah, and Z happens to be a two-dimensional array, so it has other data in it as well. But then I now have an array called, let's call it A, and A needs to be 15 elements in size. Where would that go? Where in this array here, or this representation of my RAM, would this go? Would there be any space? It can't go anywhere.
Nowhere.
It can go nowhere.
Unless you push over Y.
So therefore you would now have to go into your settings and run your optimization. But guess what? It would take a few minutes to realize that you're trying to do a process and this process is not happening. It's basically frozen. Your computer is not doing what you want it to do. And then you sit there for a while wondering what's happening. And then you figure out, maybe I should go to my settings and optimize my programs. Then it would start shifting over or shifting things and you're able to free up some space. Now that takes time, and depending on what process you're running, it might be dangerous to actually wait for this to occur. So this is now where dynamic programming, dynamic arrays come in. Don't mind my handwriting, it's still shaking, the screen is shaking. Dynamic arrays. And what dynamic arrays do is that it will go back, let's go back up here, and it will choose, okay, I need 15 spaces. So guess what? I am going to choose this one, so that would be index 0, that's index 1, 2. Which one is available next? This one, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and I have my 15 spaces. You notice these now the elements of the one array, which is array A, they're not beside each other, but they're making use of whichever space is available. All right? And what that does, it doesn't slow down your program in that it doesn't have to wait for space that is 15 elements, 15 floating numbers, a space of 15 floating numbers to be right beside each other. It doesn't have to do that. It will take the 15 elements wherever it can get it. It will choose one that is right next to the space if it is available, but if it is not available, it will choose the next one that is available. And that makes your programming a lot faster, or when you're running your program a lot faster. It does have one small negative in that the storage space, say you have 2 here, 3 might be very far away from 2. But that's not too much of a problem anymore, because with solid state memory now, it's not too bad anymore. All right, so it doesn't slow it down much anymore. No, dynamic arrays. Pardon?
You can't afford solid state memory.
You can't afford? Well, most laptops are gone solid state now. You know. So you will soon have to afford it. Yes, sir.
Yes.
Yes.
Are you saying that we should use dynamic arrays for all the time? Because what's the disadvantage?
No. You see, you have to weigh it up. Static arrays, all the elements are there beside each other. All right, it is there. So that makes the operation, once you have that space declared and reserved for your static arrays, what happens is that the space is there, it is reserved. Okay, so using the array will now be faster. However, if the space is not available, your array cannot be declared. With the dynamic array, it makes your programs a little bit faster in that it reserves the space only when it is needed. That's one. And it will reserve any available space that it can find. It does not need to be beside each other. They do not need to be beside each other. So you have to weigh up what it is that you want to do. All right. Now, we looked at how we declared static arrays using this method. Now let's take a look at how you declare a dynamic array. It's a little bit different, because with a dynamic array, what you do is to establish a pointer. All right, you establish a pointer, and you let that pointer point to an address. And then that pointer that is pointing to this address now has another pointer here. And this pointer can point to that address, and so on. And then this one now would point all the way around to here. So it takes a little bit more time. And then this one points to here, and so on. So in a dynamic array, what you are using is a series of pointers. Each of these pointers point to an address. All right? Now, how do you actually go about declaring a dynamic array? Start out with declaration. All right, so the declaration first is to one, declare a pointer. And then the second one is to point to a new address. And then after that, you can use your array as you would use a static array. Very simple. All right, now let's see. So the first thing we're going to do is to declare a pointer, and I'm going to declare a float. All right, so how do you declare a float pointer called A? Anybody?
Float,
Float.
star,
Star 8.
Mm-hmm.
yeah, A, or normally I think you'd name like PA to show us as a pointer, you know, just good programming
No,
practice.
that's it. Float asterisk A. So we've done this one. How do we get this pointer now to point to a new address? Remember last week when we were doing pointers, I say pointers can only point to addresses. So we then allow it to point to the address of a variable. Now, in this case, we don't have a variable yet. We have to make a variable and we have to let it point to that variable. So we say A is equal to, or you're assigning to A an address, which is new float. And now this is where the array comes in. Square brackets, and within the square brackets, you put the size of the array. No, you don't need to put in zeros there. You can if you want, but you don't need to. And also, the size of the array can be anything, including 0. And that's my array. What's the name of my array now? The array name. Array name is A. You want to try this out? And that's it. That's all I need to teach you about dynamic arrays, because you can use this array in the same way as you use a static array. And the beauty about it, you don't have any fixed number of elements in your array. You can have an array of 1 number, or you can have an array of 52 numbers, or you can have an array of 356 elements, or you can grow your array as you need. So that is the beauty of the dynamic array. All right, let us try this. And I was going to write it from scratch, but let me just open one that we did last week and modify it. Okay, so that doesn't want to open. There's arrays. Array 1. Okay, so why doesn't it want, oh, array 1, okay. So this is the one that we had last week. You remember it? We have an array called X. We declare X, and X has 7 elements, and those are our elements. And we did the output. Maybe we should use this one. So I don't want to have to go through and do the input like that using this method. Let me go back and open the other one, array 2. Get this one. And save it as something else. No, this is the declaration that we used before. I'm not going to remove it. I'll just comment it out because I want to now utilize the same array. If I save this and compile it, you will see that it does not compile because it doesn't know what this is, what X is. It wasn't declared. Okay? Everybody with me?
Yes, miss.
Yes, miss.
Okay. It's a reluctant yes, miss, but you're here. So using the method that we had, and this was an integer array, so I'll declare it as int asterisk. And what's the name of the array X? So that's my pointer that I have created. And I'm now going to add the rest of the declaration where I say X is assigned a new int. And notice the word new changes to a reserved word color. New int, and I'm putting 0 in there. All right. I could put 7 if I wanted to, but I'm leaving it at 0. And that's it for the declaration of my array. All right, because X, which is a pointer, is pointing to a new integer. We don't know what address it is. We just know we want it to point to a new integer, and it is creating that new integer. Just so happens that this integer is 0 for now. Okay. Now, if I save, cancel. If I save this and compile it, it should compile, and it does. Will it work? Let us see, because if you notice, look at what I did here. How many elements do I have in my array right now at declaration?
None. Right.
How many?
One, miss.
No, I have none.
Yeah, none.
Besides 0.
Gotta go from 0 to 0. Which
It
is
has
no.
0. I'm just saying that my X can point to a new integer. But right now it's 0 integers it is pointing to. But guess what happens? The minute I do this now, where I get to this for loop and I enter the first variable in xi, it goes into the first element of my array, which is x0. So it now finds the space and holds on to it, and it is now a part of my array X. And then it does that as we can grow our array as we want to. And I want you to tell me if you think this program is actually running any different from how it ran last week. I have 2, 3, and 4. Is it running any different?
The last variable, miss.
The last variable. And that last variable always gives me problem. All right. So let us see how this worked. So we're fine with the input. We're fine with the squaring. Let's run it again just to make sure we know what we're doing. 2, 3, 4. So we have the square of the 2, 3, 4. And then we were supposed to have the addition, weren't we? So we had the the square of 2 is 4, square of 3 is 9, square of 4 is 16. And then what were we supposed to do? We were supposed to sum all of these and output x6. And that's what we're getting incorrect, the output. So I'm going to move this output from here and place it within the loop and see what happens. Change this to xi. No, not xi. Is that what was supposed to happen? Let me look at this program again. x6 equals x6 plus xi. Now say out x6. All right. Save, and I have to close this. Compile and run. Let's see if it gives us anything different. So it is giving us something different. It is not giving me the last value of x6. Oh goodness. I'm gonna have to find one that was done already. Gives me those. But it is not giving me the final value. All right, I'm having a little bit of a problem with the summing of the array, but just to say that when you're using a dynamic array, let's just scroll back up. When you're using a dynamic array, the only thing that is different between a dynamic array and a static array is how they are declared. Nothing else. The dynamic array uses pointers. The dynamic array, the size of the array will change as you increase it. And that is based on need, nothing else. All right. I think I'm going to try something else here. Declare a new variable called y, and use y to store the sum, a static value. And use y here instead. See if it gives me what I need. All right. And run it. 2, 3, and 4. Now we get the correct value, which should be 38. Okay. Everybody okay with that?
Yes, miss.
Any response? Does this mean that you're all okay with this?
Mister, I'm not following that last part. What you did?
Okay. All right, let's remove this. So what I did was to, instead of using x6, I just changed it to a variable y. So y is equal to y plus xi. So I'm using y to sum, to hold the summation of the values of the elements in array X? Hello?
Yes, Mr. I see what you did.
Okay. So that's Mr. Thompson, it was. Anybody else?
Yes, yes.
Everybody's gone? Okay, KF, I don't know who KF is, but I'll see when I look at the email addresses. All right. I don't really have anything more to talk to you about with dynamic arrays. If you have any questions, ask me now, because I want to move on. Really, dynamic arrays, there's nothing more to talk about apart from just the, nothing different about a dynamic array, because a dynamic array, the only difference, as I say, is in the declaration, nothing else. And how it actually uses up the storage space in the RAM or even in your hard drive is not your hard drive, your secondary storage is a little bit different from a static array. All right, it uses whatever space is available.
No, Miss question, Miss.
Mm-hmm.
Miss can say a variable holds two array.
What?
Can a variable hold two array?
No, an array is an array.
Yes,
I'm
but
not understanding.
two separate.
So you're talking about a two-dimensional array. Can you have an array that has rows and columns, or are you talking about a class having more than one array in it?
Two-dimensional.
Okay, a two-dimensional array. Okay, let us move on then. Let us see. I want to get to a new page. Oh, dear. Specialities. Two-dimensional arrays. Okay. Now we know how we declare the one-dimensional static arrays. I'm going to stick with static arrays here because a two-dimensional dynamic array is a little bit tricky, and I'm not going to ask you to do that. Nor am I really going to ask you to do the two-dimensional static arrays, but since you've asked, we can take a look at it. So we know for the one-dimensional, we can have an array X. We could say int X. 5 equals, and the curly brackets now 0. All right, that's a standard way of writing the array declaration. And you know what will happen is that you'll have an array called X with 5 elements being declared filled with 0. Now, with two-dimensional, we have this a little bit different now. No, we're able to say instead int X, and now we say how many rows, 5 rows, and also how many columns. And we could have 6 columns. Sorry, 5 columns, 6 rows. So it's, no, sorry, rows then columns. 5 columns, 5 rows, 6 columns. And in a case like this, again, you can fill it with zeros using the same method. Okay, and what that does is that it creates an array that looks like this. Let me see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. No, that's 6, or is that 7? 6. All right, so this is what your array would look like. And you would fill it with 0. Okay, all filled with zeros. Yeah. Now, how would you actually know the indices? Because again, this is a simple array, and you refer to each element of your array by the index location. All right, so each index, and I have to use my pen for this because I don't have the space to move it right now. Each index would have, that would be, oops. Where's my pen? You would have, this would be 0, 1, 0, 1, 2, 3, 4. The 2. And for the columns, this would be 0, 1, 2, 3, 4, 5. All right. So if you wanted to access this element right here, how would you access it? You would state the name of the array. Sorry. You would state the name of the array, and the name of the array is what? X. And then you would say which row and which column. So this would be what? Row what? Row 0.
0.
That's in one square bracket, and in the next square bracket, you would put 3. So if you wanted to put anything in there, you could say you want to put a 56 in it. That's how you would do it. And then this would now be 56. All right. And you can use your 2-dimensional array in whatever way you want, in the same way as you would use your the elements of your 1-dimensional array. The only difference is that it has both a row and a column. So in the declaration, you'd have to declare the number of rows and also the number of columns. The indices would start at 0, just like your 1-dimensional array. You refer to each element of your 2-dimensional array in terms of row first, then column. Somebody was going to ask a question?
Yes, miss. You're saying this is how the computer stores the arrays when we enter an array?
For a 2-dimensional array, yes.
Okay.
Okay. You can also have 3-dimensional arrays and 4-dimensional arrays. The only problem with those is that once you go past two-dimensional arrays, it gets harder and harder to picture in your brain. And once you start being limited in how you can picture it, then you have a problem. You start messing it up. So I would say to you that if you don't have to use more than a two-dimensional array, don't use it. Stick to your two-dimensional arrays. You can get around it by having an array of objects, and within each object you can have an array. And see, you have multi-dimensional arrays. So you can have an array within an array. Okay, but that is quite complex, and I am not going to recommend that you do that.
Miss,
Okay, ladies and gentlemen,
are you hearing me, Miss?
I am not,
Somebody
somebody
talking with the
is
mic low.
whispering, but I can't hear. Your mic is very low.
So like in the back of a hill, brother.
Who was that? You want to type it in the chat so that I can read it out to your class?
Are you hearing me now, Miss?
Yes, Mr. Prater, I'm hearing you now.
Yeah, I was asking for the two-dimensional arrays. It is always 5 rows and 6 columns.
No, no, no. It can be anything you want. It just has to be an integer. It can be one row, and a one-dimensional array has only one row and X number of columns. A two-dimensional array has n numbers of rows and m number of columns, meaning that you can have a two-dimensional array with 29 rows and 385 columns if you so choose. You can have any size two-dimensional array or one-dimensional array as you choose. The only restriction with arrays is the size of your RAM, nothing else. The available space in your RAM. Now, RAM sizes are very large now, so you don't have too much of an issue, but I can tell you when I just started teaching this module, array size was important.
Yes.
But right now it's not too important, but it's good to know.
Miss,
Yes?
you said integer. So where you have int x 5 and 6 in square bracket, you couldn't use float.
Yes, you could use float, you could use double, you could use a class name if you choose, you could use char if you choose.
Oh.
It just depends on whatever type of array that you need.
Well, so when you say it has to be an integer, you mean inside the array it must be integer.
That's right. Inside the array can only store integers. If you try to store anything other than integers, you will lose data. Everything that comes after the decimal point will be lost.
Okay. All right, miss.
All right.
Miss, Miss, in our chart, does it only have one string terminator or two at both ends?
Say it again. In a char?
Does it have one string terminator or does it have two? Like at both ends or only at one end?
Let me see now. You are trying to understand how to use a char array. Hello?
Yes, Miss. Like I'm thinking about like say I'm using a char array and I'm going from from say from the right to the left. Should I? Oh, no, no worry about the questions. Kind of already figured it out.
All right, if it is that you have a question on it, you want to type it and send it to me and I can respond. Figure out the question and type it and send it. Whether you can send it via chat. Okay. All right. So I'm gonna leave arrays here. Let me save this. All right. I will modify it so that these numbers come up when you get it. Okay. And now I want to move on to inheritance, but I am going to ask that we take a small break. It is now, what time is it? It is now 5:18. Can you get back at 5:25? All right. Hello.
Okay, miss.
Yeah.
Yes,
Don't go too far. Don't stay away too long. Okay.
This conference will now be recorded.
By who? Where we kick in this?